Welcome to another day in the life of a commercial gas engineer. I was draining down this chlorophyll in order to change a three-phase element, but it was taking a bit of time, probably half an hour to an hour, and it was still not even there yet, so I just decided to snatch it. I had my Loctite on here and my jointing compound already prepared. I'm going to rewind and show you what I did beforehand. So this was tripping the breaker in the PLC or the control panel or the BMS, whatever you want to call it, and I came here and threw a cable tie for it, booked up a new part, and so this is the unit. We call it a direct cylinder. Alright, here's the destratification pump. The destratification pump is there to create an even temperature between the top and bottom of the cylinder. Like some people call it top to bottom pump. A few more components, PRV out there, and there's my isolation valve. Let's hope they hold. I don't know if they were holding, to be honest. As you could see, I had been draining for a little while. Maybe if I just waited a bit longer. And yeah, there's a fuse and also an overheat starting in. This shows you what there is. And then here is the Hamworthy cylinder details. 292 litres. DN25. Diameter nominal 25 for the PRV. And there it is, going down there. So I isolated the power to the D-strap pump and to the return pump. So there's the return pump over there in the control panel. Gonna switch things off as well. It's good to have 2 points of isolation if possible. So when you're doing safe isolation, try to have 2 points of isolation. And it's good to label up things. When you diagnose that something's not working, it says 2 or 3 boilers in a plant room. There's my second point of isolation. Try to put labels on things for other engineers when they come into the plant room. Okay, time to isolate our valves. Try to remember to open up valves slowly when reinstating, instead of throwing them open. Closing them can kind of be quick, but opening them up, I forget at times when I open up valves very quickly, and it can cause a big shock to the system and things can pop. So just try to remember when reinstating to this open valves slowly. Here's the drain off I'm going to use. I love my Testo 770. This was gifted to me by someone on a course. The engineer gave me those. So 5 bar. It's not working. This PRV seems a bit dodgy. Gonna open up the other PRV. Nothing's coming out of this hose. So there's a few ways in some of these control panels. Some of the doors and the isolators actually work. So in this one, it's just underneath. You just give it a little poke, and then there you go. You get inside. My immersion heater. I'll flick this off. Even though we've got the local isolator off, I'm going to just switch this off too. Against the left, next to my neutral bar. That's off now. We still need to check for isolation. Notice I've got my boots on. When working on electric, try to make sure you've got a decent pair of rubber boots on. I'm also using my volt stick. And I'm going to test my volt stick first to see if it's actually working. I've got 2, one's not working. Notice there it's working. Okay, great. I've tested it on a known source. And I'm going to go in here and just make sure there's no power. And then I'm going to get my multimeter out I should have a proving unit for my multimeter to make sure that my multimeter works. So if I had my proving unit here, it's in the van, but I could just prove that my multimeter is working. But another way of checking your multimeter, it's better to use a proving unit, okay? But I'm just showing you, if you do not have a proving unit with you, this is a way that I test my multimeter when I don't have my proving unit with me. Okay, this is another way of checking that my multimeter is working, because the leads may not be in, the leads may be damaged. Make sure that your multimeter is working. I'm convinced that it is. You should still check after you've tested that there's no power somewhere, or that there is power somewhere, etc. Just check that your multimeter is working afterwards. 10 points of isolation I'm going to write down here. Here we go. So your 10 points of isolation when you're working on 3-phase. Okay, so I've got my earth. I'm going to test from my earth. You want to call it out? To live 1. My earth to live 2. My earth to live 3. My neutral to live 1. My neutral to live 2. My neutral to live 3. What next? My live 1 to my live 2. Live 2 to live 3. Live 1 to live 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm missing one. What is it? Can you guess it in time? My earth to neutral. So this is my 10 points of isolation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So remember, that's how you check it's working. So with your hands, try not to use your bare hands when you're working on electric. Try to wear gloves. And also use VDE rated screwdrivers up to 1,000 volts. I've got a cheap pair of Draytons. And also side cutters and long nose pliers, you want them to also be VDE rated. And treat things like they're live, okay? So that's locked. Also the plant room's locked, okay? So I'm locked in the plant room, so nobody can come in so easily and turn things on whilst I'm working. All right, so 2 points of isolation at least, and on the panel I've turned it off. I've removed the leads from the thermostat. I've locked the door to the plant room so nobody can walk in and just turn the power on from the public. The powers that be in the building know I'm in there. Always let someone know that you're working. When you're on your own, make sure that your partner or your colleague or somebody knows that you're somewhere on your own, and if they don't see you by a certain time or hear from you within a certain amount of time, there's nothing stopping you from doing your extra measures when you're doing safe isolation. So I don't know if you can see my wires being marked, so take pictures of your wires and mark them as well clearly so that you can identify, or use tape. I think scribes with a marker pen can help at times, but you can wipe those off. So here I am checking my earth to neutral, and that's the voltage I've got there. So I'm going to write down what I had. So 0 volts. Earth to line 1. We're going to call line 1 up here, this one at the top. Earth to line 1. Voltage 0 volts. Okay, I've checked the other ones, and then now I'm going to swiftly move on to, I'm going to check my neutral. I'm going to check my neutral to my live 1. So you get the gist of me checking the other parts. So I've swiftly moved on now. So I'm checking neutral to live 1. And then I'll do neutral to live 2. And neutral to live 3. So I'm continuing to check for safe isolation. Then I write down what I found, and then I'm going to do live 1 to live 2 and so on. So I started, whilst there was still water in the system, as there's still a bit of weight in the system, it's better then to just loosen up the element whilst the cylinder's still heavy and you've got something to work against. I'm moving all my parts out the way to stop them from getting wet. There's one I prepared earlier. So here I have my Loctite on there, my paste. Okay, now fast forwarding again now to having the unit in situ, the new element. So I've got the system filling up whilst I am going to wire this up. I have wired up my phases and I'm tightening up. A nut driver would be better for this, but this is what I have on me. I don't have any nut drivers, so I'm making sure they're all tight. So I didn't use any new connections. I can't remember the name of these crimp connections. So I've used those. I'm trying to make sure that the phases don't touch each other or the earth touch anything. Okay, and then now when putting in my, look at this wire, I'm going to just see how deep it goes inside. So, and how much space there is, how much movement there is, if it's going to make a good connection or if it's going to just fall out. So the hole looks wide, got a big diameter there, so I'm going to strip this wire back and double it over. So can you see, trying to double it over and pull it inside so that we have a good termination. I don't want any copper showing, I don't want any of the wire showing on the outside. So here we go. I've got the left in, left and right, making sure it doesn't come out, and also that I don't see any copper showing. So I'm just doing a last little recce to check. Look, I just found something loose. So always double check. But before I turn the power on, I'm going to just check what it says. Okay. Alright, use a spanner. Okay, I used that spanner. I didn't use a nut driver, but a nut driver would probably be more convenient. All work should be carried out by a suitable qualified personnel. I hope that's myself. Heaters must be handled with care and stored in dry conditions. You can read along on pause if you want to read any of this. Okay, just skim read it very quickly. Sometimes you can learn things from the manufacturer's instructions. Screw supply, connection. I think when installing, instructions are ultra important to read. Obviously, whilst carrying out maintenance work, instructions are important. But when you're installing, that's where it can all go wrong. Because you're the installer, you're the person who's gonna, if you install it wrong, you can have problems for the person afterwards. Talks about monthly and annual checks. Carry out all 3 monthly and 6 monthly checks as above. Oh, wow. Check the terminal box is clean and dry internally. Check that the electrical termination are intact and secure. Check the heating element insulation resistance at least 2 mega ohms. Oh, okay. Refit the new gasket or O-ring. Oh, I think I didn't do that. I'm going to have to go and put the O-ring on. I forgot the O-ring, so that's why it's good to read through the instructions. And leave the instructions for somebody behind as well afterwards. Alright, and then the wiring connections here. On the right, Fig 2 is the one we are doing. Let's get this on. Alright, we've put our other point on. Our MCB is on. We're turning on our pumps. Our D-strap. Let's turn on auto. Let's put this to hand in a moment because something strange is going on. Let's put it on to hand. Alright. Make sure that's not tripped. Let's check over on the left. Yep, we got power. Okay, I could also check my live 1, my live 2, and my live 3 here. Can you see 344 up here on the top right? Different connections here on the side, probably from like a switch from the panel, the switch, and one would probably be like error signal. Okay, so we've got it all in auto now, and the immersion is calling for heat. Put a date on the unit to just say this is when I installed it. Here's the old element, and then here is my rise here. So in the comments I'm going to put the way of working out how quickly the temperature should rise based on the kilowatts and the liters. And here we have our return, secondary return, and then it's good to flush some taps because other people in the building may be shocked when they hear the air and the pressure when they open up their taps. So flush some taps, and also the water's been up for a while, so you can do some 5 minutes tap flushing. Moving on to another plant room. So I went to this plant room And I didn't come here to see boilers in and lockout, but lo and behold, I just came to get some water samples of the heating, and look, they've got a fault on this boiler. Any ideas of what to do? What would you do next if this happened to you? What would you do? So I just checked the Billy Basics, the pressure. I think I looked in the manual to see what that fault code was. So it's a Remea Quinta 45. I reset the boiler and then it came on. I had a boiler on the left that's off. I found it off. I don't know why it was turned off. There was no label on it. The power was off. No warning notice. Interesting. So I'm watching the temperature rise here. And this is the stage it is in. Stage 3 heating mode. I didn't see any flame. I didn't take the case off, so I didn't see any flame. But I can see I can see code 3 means heating on, and I can see the temperature rise. I don't know if these pressure gauges are working on these boilers. That could be the reason why it had a problem, but I doubt it's got 0 bar in there. Okay, so looking in the manual, I can see that code 2, and then I had O2. So it said operating mode during failure. And then this is the system, this is the drawings, and so on. So here I have my 2 boilers. It's connected to a low loss header. It's got some pumps underneath here. And where we've got MCC panel boiler room, air sensor. You've got your TL, should I say, your thermal links above the boilers. Always look for these. Make sure you've got thermal links above boilers. I saw some boilers recently which didn't have thermal links and made a note of it. Always spot the difference when you're in a plant room. STR, that looks like strainer. This is a service valve. They have a chart on the right to tell you what these symbols mean in case you don't know them by heart. Low loss header, so then we've got de-aerator. Sometimes you have air and dirt separators. We've got the de-aerator there. Then here we've got a dosing pot. Okay, and there's more parts over here if you want to pause and read. You can see these are our mega flows that we have in the plant room as well. And then over here we have cold water tank. Okay, I'm at another job here, and in this site hot water is back on. I came here for a hot water problem. The element, I found it off. I was wondering if it had tripped or if someone just turned it off. This is my hot water pumps, my heating pumps at the bottom. I have that isolated because I was starting to get a bit of heat going through the pumps even though they weren't on. And then this is my bad boy boiler. This controller here, let me know if you're familiar with it. So I went to it and I tried to do my desired hot water temperature and turn it up, but it wouldn't work. So I had to turn up my desired temperature to 30 on here, which I believe was for heating. Here's my element over here, my immersion, should I say, heater. Okay, so it's gone up in temperature, so the immersion has tripped. This boiler here is a bit corroded. It was made or installed in 2011, and I've been asked to change a few parts in here, but I do not want to touch it because it feels like a setup. There's times where you'll end up on a job where you will feel like you have been set up, and this is one of them. So here we have it. We're draining it down into here, nice and convenient. But I am going to have an attempt at working on this boiler, but I'm not going to rush in because they have hot water in this building. The boiler is not leaking. It's got signs of a previous leak. You have to be careful not to get yourself into trouble because you can get complaints. Don't do everything for money just to make money. Be careful because you can cause problems when you do that. Think about what you're doing and if it's logical. So there's a few parts I've been asked to change from somebody else. I haven't booked it up, but alright, I'm checking this element now. The resistance, look at the resistance on this element. I've pulled out my thermostat, I've taken a laser, and look, it's just moving about. It's here, it's there, it's everywhere. Look, I think it's stabilized at some point, possibly at 8.7, but it should be about 19. So on these, so you've got the year is here. So it was installed in about 2011. and I believe it was week 43. These are the parts I'm supposed to change on it, but as I started to take this part off, it was too tough. I could have sprayed it, I could have heated it, I could have hit it, but I was getting calls that they wanted the hot water back on, and I didn't have an emergent element working. It needs to be changed, and if I had my emergent element, I could have just turned the element on, kept them with their hot water, and then worked in peace. But don't work under pressure unnecessarily, and think about what you're doing, what the point of what you're doing is. That's what advice I'd like to give you when you're doing something. Don't think money, 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 because you can end up in hot water. You can end up in problems. This is the element. It was 3 kilowatt. It's working on this boiler. Haven't worked on it in a while, and I had to remember that you have to press left and right to get it into high and low fire, and then it will give you an option of partial load or full load. And then here we go, you have to press this button and then it starts flashing. You can turn to full load and then press, and then it should go into full load or partial load. And always remember to turn the temperature up on the boilers, the desired temperature on the boiler, so it doesn't cut out too quick. After you need to do it on many boilers, and get your pumps going, get your extract and get your extract and supply fans on, because the boilers are probably interlocked. You can sometimes get boilers into service mode even without the extract and supply fan being on, and the boiler will come on. But with a natural switch live, the boiler won't receive a switch live when the supply and extract fan's not running. It's interlocked. So here we have it. The boilers, to stop the boiler from kettling, we need to have the pumps running, so we need to force them on. Also the heating pumps as well, and so on. Put it all in hand. And remember to put it back. On this particular boiler, I had these points here that were completely corroded, had holes in them, and I changed the probes. You can see the detection there, and you can see the spark there, the condition of it, how different it is. Do you spot the difference? I changed that, and I checked my knockoff button that it was working, my safety knockoff. There's my solenoid, which activated, and my PRV needs to be changed because that's the year, and every 5 years or so, due to insurance purposes, normally they need to be changed, so this one has to be. It's got my DN number there, DN diameter nominal 15, my bar 3.2 bar, and then leave everything afterwards as I find it, not in hand but back into auto. And there's my supply. I had to use my anemometer on the supply low. This is the extract high, so I can check up here. It was 5 meters per second, I believe, or something like that. 5 ms on the low, on the, should I say, the low air inlet, and then it was about 2 on the extract. When you see things like this in plant rooms, combustible material, or in a gas meter cupboard, make a note of it. Just put it in the comments, in the notes on the service, that avoid. They're not going to do anything, they're not going to change it, but just recommend to them that if the building goes, the boilers catch on fire, this is all going to just add to the fuel quickly. And this was the hole in the flue. I mean, carry your plugs and caps with you. Make sure you've got various sizes when you work in the commercial power, and get your company to order you some. And there we go. It had a hole in it. This will probably corrode. I think it may be because the boiler is working at a low temperature for an efficient condensing mode, but I reckon if you turn it up higher, the temperature on the boilers, potentially it may not corrode as much. Give me your ideas on why you think there's so much corrosion around this flue. I think it's because it's working a lot in condensing mode, so a lower temperature, maybe 50-60 Celsius rather than 70 to 80. But it or something to do with the traps, maybe something to do with the traps not being proper operational, or not enough traps in there. But let me know in the comments below what you think was causing this problem. Check your carbon monoxide alarms are in date. Test. All right, thank you for joining me. Please leave comments in the section below. We can all help one another. Big up, if you're still watching, big up the guys in Australia. I've got quite a following in Australia. Let me know where you're watching from, in what part of Australia. Also in America, please let me know where you're watching from. I'd love to know where you're seeing it from. Tell me something about you. These videos are not all about the YouTuber, but about the viewers. So let me know something about you guys if you worked on any of these boilers. Thank you for your support of the channel. Thank you for watching. If it's your first time, let me know. Tell me something, man. All right. Until next time. Bye.